Good evening and welcome back. I hope you had a refreshing break and are ready for our next session, which promises to bring even more excitement to your teaching practice. Our second session is titled Hands on and Experiential Learning in Science. In this session, we will explore how you can transform your science classroom into a dynamic, inquiry driven environment that sparks curiosity and fosters deep learning. We look at engaging activities and strategies that make science not only more interactive, but also more impactful for your students. We are thrilled to have Dr. Adita Joshi as the speaker for this session. Dr. Joshi is a scientist with extensive experience in science education and communication. She has a PhD in zoology and has conducted postdoctoral research at NUS Singapore. She has worked with esteemed organizations like the Mayo Clinic, Inside Out, CSIR, IGIB, and PIFAZER. Based in New Delhi, Dr. Joshi combines her passion for science with her love for the arts and family life. Dr. Joshi's session will provide you with practical insights on using hands-on experiments to bring science to life and create an experiential learning environment that will excite your students and foster a deeper understanding of scientific concepts. And participants, after this session, we'll be having our CPD quiz. So you just don't have to go anywhere. We'll be pasting the link for the CPD quiz in the chat box itself. Before we begin, let's review some housekeeping details for today's session. Participants will be muted throughout the entire session. Please ensure you have a pen and paper to note important information. The chat box will only be enabled during the Q&A round and as required by the speaker. To receive your e-certificate, please fill out the feedback form that will be sent to your registered email address on Monday. Don't forget to participate in the quiz today after this session. And as I already informed, we'll be sharing the link for the quiz in the chat box. Now, please join me in welcoming Dr. Adita Joshi, who will guide us through the wonderful world of experiential learning in science. Adita ma'am, over to you.
Thank you, Yogendra. Am I audible, Yogendra?
Yeah, ma'am, you are perfectly audible.
Okay. And will the chat be open in between?
Yeah, ma'am, chat is open for all.
Chat is open
The participant can type their queries and questions.
So, hello everyone. I see huge number of teacher participants joining this webinar. The number has crossed 400 as of now.
Ma'am, they are still joining.
And they are still joining, right? So, thank you, Yogendra, for the introduction. Now, today's session I'll be essentially talking about some of the basic fundamentals and theories behind hands-on experience and experiential learning when we talk about in the context of student learning and learning in general. So I will not be touching specifically about how to create a lesson plan because I understand you all are much better at it than me, but we'll walk through some of the concepts which anybody who wants to bring inquiry into their science classroom should go and visit and revisit rather. Okay, before I begin the session, I will just like to pose a question to you all while I'm sharing my screen. How many of you are aware of the theory of constructivism? You can just type a yes in the chat box if you are aware of the theory of constructivism. So some are saying yes, some are saying no, some are saying heard. Okay, so lots of you are saying yes, few are saying heard, few are saying no. Good. Okay, fine. Okay. Can any one of you just one message in the chat about what is constructivism in one line and answer this question from a student's perspective? I need only one answer in the chat. Okay. Okay, that's all. No need to answer more. Kalaivani K says that creativity is what constructivism is. Rajaya says building knowledge from experiment is what constructivism is. Vaishali says top-notch ideas. Samila says new ideas. Nasiha says constructing knowledge, building ideas, building knowledge from experiment. Okay, very good. Independent learning. Okay. Preserving traditional values, customs, and institution, which is what Pavni thinks. Okay, so we'll just stop here, and I will say that all these answers that I'm getting. Somebody is saying opportunity for students to learn themselves. Constructive learning is a approach where learners actively construct their own knowledge and understanding through experiences, interactions, and reflections. So, Monica Kondapalli has actually given me the original definition of what constructive learning means and on which the principles of constructivisms are built. Good. So, if you can see my screen, let us focus on the screen and take away our knowledge from the chat box. Okay. Right. Can you see the slides, Yogender and Yogender?
Yes, ma'am. Now it is visible.
Okay, fine. Yeah. So when we talk about hands-on experience literally means that students need to do some things using their own hands. Okay, literal meaning is that. But when they are doing things by using their, motor skills, using their hand eye coordination and all those things, something is also running at the back end, which is, the thinking part, the mind part, the brain part, wherever all the theory of, learning and all these things are based on. So how do people, or how do learners, or how do young children, they construct their knowledge? So this is what constructivism learning theory is all about. So they construct their knowledge based on what they see around, right? So what they see around, and in the context of students and teacher, what the teacher is providing a students, what kind of an learning environment the teacher is creating in the classroom, what kinds of teaching aids or what kind of other kind of materials a teacher is able to provide to the students, that all becomes the environment of the student, and which is where the whole part of interactions with the word come into place, and which is where students start constructing knowledge, students start constructing certain ideas, right? So if we are talking about, say, kindergartner students who have never seen a four wheeler car, right, who have never seen, suppose, imagine, this is a very imaginary scenario where there is no four wheeler cars around, they have not seen it, and you just show them a three wheeler something, their idea of a moving vehicle will be based on only three tires and not four. So essentially they will think, oh, something can run on three tires, and when they go out and see a four wheeler car, they observe it and they say, hey, I see something which is different from that. The principle is same, something is moving on its own, but here we have four wheels. So what the background knowledge is, what the new knowledge is, based on that, students can think, oh, is there something which can be built further than this, or how does it work on three wheels versus how does it work on four wheels? Okay, so those kind of questions a student will be able to ask and answer. So this is what I gave a very basic toy kind of an example, but you can extrapolate at every grade level for different kinds of scenarios. And this is how student build learning, by watching something, by constructing meaning out of it, and then sort of thinking critical questions, that what are the differences between a three-wheeled vehicle versus a four-wheeler vehicle, and then they start building on that knowledge, and then they go layer by layer, layer by layer, layer by layer, how does the whole thing works. Okay, so these are some of the principles. And constructivism learning theory essentially focuses on empowering students to explore and engage. So they explore things and then they engage. engagement means very different. So engagement doesn't mean that somebody is listening to you, or somebody is observing something. Engagement is much more beyond that. Engagement is when you are actually trying to imbibe all that in yourself. So you are totally involved. You don't need any other person, whether it is a teacher, whether it is a peer, whether it is anybody, to lead you further. And this can happen at every grade level, right from grade 1 to higher grades. If a student is engaged, if the student is really wanting to do a particular thing, or wanting to explore different facets of a particular questions, they would essentially lead themselves. Then the teacher's job become much more easier. So we'll walk through some of the other principles of constructivism. uh, Now, how do you sort of place it in your classroom? So for engagement, you need to have well planned classroom activities. So when you talk about planning classroom activities, activity could be anything. It could be simply looking at a beautiful piece of art where some science is displayed, and you can ask student that, tell me what is happening in this picture, and where is the science angle to this picture. Okay, so what kind of color combinations are happening here, and then you can build around that. How do colors mix? What is the chemistry around colors? You can build different from different angles. This much is very easy for them to get engaged. So activity can be as simple as just putting a picture in front of the students and asking them the right kind of questions. So the teachers need to plan the lesson, the plan the activity in such a way, depending upon the grade levels. It doesn't have to be an activity which requires lots of raw materials which you would bring on the table, and lots of demonstration. In order to start engaging, in order to start enticing them with critical thinking, these kinds of aids, simple aids, are also very, very effective. So my advice to all teachers would be, don't think of making huge activities. Start simple, and from simple things, make your students to generate big ideas, huge ideas, greater questions, rather than activity which is too cumbersome for teachers and also for students to do. Okay. The second principle of constructivism is collaborative learning. So collaborative learning is something which is very very, what to say, which is not so much in our classroom, depending upon the traditional ways of standard instruction, the way the classrooms are built, the way the whole teacher 1 to 40, one teacher to 40 students concept is there. So we sometimes say collaborative learning, or in a traditional classroom, if somebody is talking to the other students, there are discipline issues that teachers bring in, and we all know it. As I'm saying it in a lighter vein, that why are you talking to the other person? You are not paying focus. Maybe the students is discussing something with the other students. But those kind of scenarios are there in the traditional classroom. So how do we design activities where students learn from each other? Because again, I'll give you example of a picture wherein a scientific demonstration is shown or something, and one student would look at the the beauty part, the other students would look, oh, something is missing, and the third one will look, there is a machine over here. So it brings different facets when you learn collaboratively, or when you discuss on certain ideas collaboratively. The big picture comes into place with all the essential elements. So any simple activity can be done around these things, and instruction should be such that there are opportunities for students to work together and to learn from each other. Okay, so you can even build an instruction like, there are 4 people in the group, you have to look at the picture from this theme, you have to look at the picture from this theme, and the third one has to look from a different angle, and then you jot down all the points, and then you talk around it, and build your version of what is being displayed in that particular picture. So okay, so that's how the collaborative things should be constructed. The third one is, teacher is a facilitator. So let them do. It's very difficult sometimes to do these kind of activities in the classroom, even if you are staring at a picture, and if students are not speaking anything in the first 2 minutes, the teacher gets little jittery that, oh, they are not discussing, shall I throw some pointers, shall I tell them, do this or do that, because time is running out. So advice is not to do that when you plan these kind of activities. Just stay there with patience. It will not happen in the first 2 minutes, but when in the third minute it starts happening, students will complete the activity or the discussion in the 5 minutes that you have given to them. So those 2 minutes, it's not that actually they are not doing anything. The whole experience part is going on that particular time. So you have to understand that students are not simply staring at a thing, or what prompt you have given her. You have to think that students mind is absorbing what is there, and that is the experience. The student is talking to the experience without using words. The brain is talking to that experience, and that is where the teacher has to be most calm and composed. And once they start, then you can start facilitating so that they complete the activity in the right time. Or imagine another scenarios where you have put up a lot of materials on the table, and you say, oh, this is the material given to you. Make a spinning top out of it. I have given you a ball, I have given you some threads, I have given you something else, I have given you a pencil. And even when you have those materials around them, the students will look at the material for some time, and they would not use their hands to pick the materials. Some of the students would pick the material and see what is the kind of thread you have given, what is the kind of pencil you have given, what is the kind of a plastic ball or whatever you have given for them to design some activity. So there are all kinds of students, and they are interacting with whatever you have given them, whether it's a picture, whether it's a video, whether it's a materials, in a different way. So facilitation would look very different in all the three scenarios, and teachers must learn to be patient and then facilitate them uh, to the right kind of questions that they should ask. So if I am giving a picture to a students, in my mind I already have that where I want my students to lead, okay, as a facilitators. And I would be very surprised, you would I'm sure in your classroom you all would have also felt much surprised if you have tried hands-on activities which are different from the normal experiments. Students sometimes come out with wonderful ideas, and then it becomes a new kind of facilitation for a teacher, because the teacher is also not experiencing or expecting that kind of questions. So the goal should be in creating newness rather than leading students to the same kinds of question. And then new and old knowledge concepts come, which is another principle of constructivism, wherein students have some knowledge, and now you are giving them an activity or an opportunity to explore and engage. And then these students are building some new kind of knowledge. Oh, I saw I'll again give the example of the vehicle. I saw a vehicle only running at three wheels. Now I saw something which is a four-wheeled vehicle, right? So what do? I see something new. Okay, and that one looked more like a triangle, and this one looks more like a square. And both are doing the same thing, both are running on the road. What is the difference? How is the engine built differently, is the design built differently? So the concept of design also can come into place. The concept of what kind of engines are also coming to place. Does having an extra wheel to the vehicle gives the advantage of having more speed? Those kind of questions students can ask. So will a auto, which is a three-wheeler, will run maximum speed of 70, and will a four-wheeler run at a maximum speed of 200? Who knows? So these kind of new questions and new knowledge students can build around. So pick up simple activities, pick up simple examples from real life or elsewhere. I would advise not to copy different activities which are available on the internet. If you're copying them, also bring these principles in, bring these thought process in into your activity. Think a little bit laterally, okay, so that the students are able to construct some new knowledge by asking open-ended questions. So the questions that I was just throwing at you guys a few minutes back, these are all open-ended questions. So there is no answer to it. Open-ended question is something which will lead you to ask another question. Okay, which will not give you a definite answer. And this is where the inquiry part comes in, and the experiential learning, it is based on inquiry, which is the fundamental piece here, and we'll talk about it later. So open ended questions are the questions which will lead a learner to ask more questions. And the learner could be a student, learner could also be a teacher, a learner could be anyone. So example, how are bubbles formed? So children play with those bubbles, right? The bubbles that they blow. How are bubbles formed? Some children will say, oh, they are formed with soap and water. Some children will say, oh, when you dip something in soap solution and when you blow, then only they form. Okay, somebody will say when you blow at a very slower speed, then a big bubble will form. But if you blow with lot of force, bubble will not form. So from one single question you can lead students to ask these different kinds of questions and build different concepts from science. So what is the concept of force? If you are pushing air through your mouth to make a bubble, what is the concept of force? What is the concept of air pressure? How does it bring into play when you have to make bubbles? How are huge bubbles versus smaller bubbles form? Is it the way you are pushing the air through that bubble forming device, or is it dependent on other things? Some student will say, madam, it is also dependent on the soap solution that you are bringing to us. So what is the solution? How will you make different kinds of solutions to see which one is giving you the best size of the bubble? Okay, all those questions you can arise. So very simple activity, but you can do it in kindergarten, you can do it at class 10th level also, because the science concepts are all same there. So you can design this simple activity and ask huge questions, which are somehow the answers are embedded in the basic principles and fundamental theories which we read in physics and chemistry. So again, I would advise that look for simple things. Don't look for big models or big kind of things. Okay, the only thing our students are lacking in today's world is fundamental understanding of concepts. So these simple activities build those fundamental understanding of concepts in science that I have been mentioning. And the way you probe those activities, the way you ask questions. So maybe the art of asking the right kind of questions in a science classroom in the most simple manner, it is something which which we all struggle as educators. So we use a vocabulary of science, we use jargons, we use all those things, but how to ask a question simply around simple activities, which the answers to which will require the fundamental concepts and the understandings that we have in physics, chemistry, or biology for that matter. Okay, so the other element of constructivism theory is the reflective engagements. So if you give if you give four different kinds of soap solutions to student and say make bubbles and see which one, comment on the size of the bubble, comment on the force of the air that you push through, and so on, and ask them to reflect what did they find when they do it. So this is all student centric approach that you use in the theory of constructivism. Teacher has hardly any role to play here, other than leading the students to ask the right kind of question and then giving them the right kind of terminologies as they go through the classroom. Because when the students are constructing new knowledge, they don't know the exact science terminology for that. Okay, and which is the terminology you are going to introduce in your science chapter? It has to be tied up with that kind of terminologies or the scientific definitions or terms. Okay, so allow students to do reflection on what they are doing, and when they are doing the reflection, create ways of going through those reflections. If there are four groups working in a classroom, a teacher cannot go from each group to each group. So maybe you can say whatever you are reflecting, you can put it down on a paper, or you can put a flow chart of what you are reflecting, or you can simply, scribble down notes on a piece of paper. What is going on in your head? Teachers can collect all those different kinds of notes or whatever, and go through them, and then they go into the word of the student's brain, what is happening in that brain when they were engaging and reflecting in that activity. Based on those kind of inputs, a teacher can get an output which will help a teacher to design much more engaging and much more what to say, reflective pieces in um, the activities that they design. And then use assessment. So assessment, how beautifully your assessment is designed, it should catch the essence of the hands-on thing that you are trying to do in your classroom, or the experiences that you want the student to go through. So if your assessment is like a traditional assessment, then whatever hard work the students and the teacher have put through in that classroom will go off. So your assessment should also be very, very what to say, reflective of the experiences that the students are going through, rather than, okay, now you have learned the concepts of the air pressure or the force or all those things. Now what is force and what is air pressure, how it is linked to this? Those kind of run those kind of standardized questions should evade the assessment here, because that is not what experiential learning looks like. So it has to look very different from standardized assessment, or the standards that are there in the traditional classroom. So and all this what I'm talking is not going to happen in one go, in one class with one batch of students. This is also a learning journey for the teachers, which they build grade to grade, semester to semester, year to year, term to term. So when we talk about these things, and educators have been talking about these things, why are we not successful? Because we think that this is too overwhelming, and with all our challenges of a classroom. But what we fail to understand is we start gathering too much of stuff into building hands-on activities, and we start gathering too much of load on ourselves in designing those assessments, or we just do it once in a year in a classroom, and we don't do it so regularly, so we are not able to build that atmosphere. So these theories were built long back, but then they find their relevance even today in the era of content which we have on YouTube, we have on Instagram, we have on all these different kinds of learning channels have emerged. But a classroom is still classroom, so if you can create these kind of things, wherein a man is talking to a man, students are learning with each other rather than learning on a device, listening somebody on the device. I think that is where the strength lies, and that is what we should try to build. So authentic activities are something which will drive a classroom for students, will bring students into the classroom. It is not something that they can see on internet, they can see on the Google, they can see on the YouTube channel. It is something which they are creating, which they are exploring. They are not watching what somebody has explored, they are not watching what somebody is demonstrating to them, whether it's a teacher, whether it's a video, whether it is whatever kind of animated content. Here they are doing the things. So I think if you start your thread in the classroom around this thought process, the students will be immediately hooking up, and their focus will not go anywhere. So now um, we have been talking about inquiry based learning, how to build inquiry, how to make them ask questions, how to make them ask the right kind of questions on a given activity, on a given experience, on a given video, on a given flow chart or anything. Okay, so I will just sum up what I have been talking till now. It is a student centered approach, experiential learning. Student do all the work, and they do all the work in collaboration. When they do the work themselves, when they do the work in collaboration, they set themselves on a path of critical thinking. Nobody is interrupting them, nobody is interrupting their thought process. They are given some 10 minutes time to think and to act and to discuss. And this is where, the constructivism theory lies, and inquiry is at the center of it. Okay, and I have given you examples of bubbles, examples of that two-wheeler car, example of a picture or anything. So, what are we doing with all those things? All those things are nothing but you are trying to, initiate students into inquiring, into observing something and inquiring about it. Okay, just by looking at the picture, also students can see, how color merge together, and if we merge two colors, how come a third color is like that. Now this can again happen in kindergarten, and this can also happen in class 10th chemistry, because when you talk about chemistry, each element originally, if you go to original chemists and all the history of chemistry, each element is linked to a color. So how do you build things around that is what is a teacher's strength, I would say, in this in today's world, where we are also struggling with a lot of content being made around and being available to the students. Now I will again ask this question: how many of you have learned the have knowledge of 5e model of science teaching and learning? If you can type it in the chat. Have you heard of it? Okay, yes, yes, yes. Everybody says yes. Somebody says no. Good. Yes, yes, yes. I don't know what D means. Okay, okay. Premlata M, D. I don't know what that means. Okay, never mind. So yes and no, yes and no, yes and no. Has any, and okay, now I ask another question now. Have you used 5E instruction in your classroom ever? Have you used 5E instruction in your classroom? Some people are saying yes, 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 yes. Okay. Okay. Good. Not much. Some people are saying yes. Okay. So we'll go through this. Sometimes they have used and sometimes they have not. Very good. Okay. So let's understand now. Stop the chat box now, and let us get back to the presentation, and let's talk more about this. Uh, so So now at this point, I would want you to recall last science class that you taught. And now I will like those who have used the 5E model, think of the last science class where you used the 5E model, and what aspect of 5E did you use? Did you use all the 5Es? Did you use one or two of them? So think of that, and what components or teaching aids did you use? So these are the two questions. If you can type it in the chat box, answer to this. Those who have used the 5e model, how many e's did you use? You used only 3 e's or 4 e's, or whole thing you used, and what teaching aids did you use? If you can just give me some idea, I can build the session around that in the upcoming slides. So let me go through the chat, what people are saying. Okay, microbes around us, Ohm's law. Okay. All 5E somebody has. I used all five. Smart boards and videos they have used. Real objects, hands-on experience, 4E used. Okay. 3 plants around us. Okay, fine. So some people are saying that I have used these chapters. Some people are used I am only engage, elaborate, and evaluate only. Very good. So pH values ke around you have done it. You have only used 3's and not being able to use the other two. Very good. Show pictures, video. Fine. So let me see. So stop writing in the chat box now. So as some of you have gathered, some people will use a video, some of the teachers would have used a mini lecture, some would have used an assessment, a discussion, or a demonstration. So these are some of the aids that are being used in a 5E lesson. It is I have seldom seen people who have said that I have used all the 5 E's across a lesson. Some of them have used, but mostly people use the engage and explore part more deeply, and then the reflection part is not used all that deeply. And again I say, why does this happen? Why you use only three E's and not the other? Sometimes it is by the design of the activity, sometimes it is because the kind of theme you are choosing, the theme limits it. But let me tell you that on the internet, if you find, there are different kinds of lesson plans which are available on 5e model. However, the challenge there is to use those lesson plans just step by step and word by word, like that only. So which is where the success lies, and of using the 5e approach. And the 5e approach is also very what to say, it is something which is related to the constructivism theory. You can apply the theory by using the 5e model of instruction in your classroom. Now question is, did your student discuss a question in small groups when you were doing that 5e activity, or was it a whole class discussion? Can I have the answers in the chat box? So when you were doing, those of you who have done the 5e model, did your students discuss a question in small groups, or it was a whole class discussion? So, limited students only, small group discussion, in groups, whole class. So some teachers are saying whole class, some teachers are saying yes in small groups. So I'm very small circle time. Okay, good. Sometimes small group, sometimes whole group. Okay, good. Okay. So did you introduce a new concept? In what order did you introduce these components? So I am not asking this question. I understand. Did you use the 5e model in a linear fashion? Means engage, explore, so on and so forth. Did you use it in a linear fashion, step by step, or did you use in a different fashion? Can somebody answer? Step by step. Yes, in different ways. Yes, ma'am, step by step, up and down. Very good. Okay, linear fashion. Okay, good. Very good, very good. Step by step, linear fashion in different ways. Some, okay. How did you decide what came first? What is the optimal order of activities in an inquiry based science? So, if those of you who have done step by step, they will start with engage, and then they will go to, explore and explain and other thing. Now, those of you who have not done it linearly, who have done it here and there, some people started with engage, some people started with explain, some explain first. Okay, fine. So when you are doing explain, who is explaining, the teacher or the student? Answer in the chat box. Are you explaining it to the students, or the student is exploring? Teacher. Kondapoli Monica say, I explained. Teacher, teacher, teacher. Student. Okay. Student, teacher, teacher as well as students, teacher. Most of the answers are around teacher. Okay, good, cool. So stop the answers in the chat box. I have gotten my answer. So what the chat tells me is, some of you are using 5e in a linear fashion, some of you are not using in the linear fashion. When I asked which order did you use, most of you said that I used engage or I used explain. When I asked you who explains, most of you said that the teacher explained, some of you said teacher and students both explain, and then very few of you said student explain. Now here is the catch. Anything which is based on constructivism, anything which aligns with the constructivism theory, whether it is inquiry, whether it is the 5e model, you have to remember something. All the 5e's in the 5e model are for students, they are not for teachers. And the explain part is more on a student. Why? I will tell you. I will move the slides further. So now you all know the models. I'll go quickly. Engage is, you can use short activities to promote curiosity. You can and this helps to clear some of the misconceptions. You can also use novel questions to engage. You can show them a demonstration, a video, or a powerful visual, or you can just take them out in a, if it's an outdoor activity, you can just take them out and say, watch what is happening. So these are different ways of engaging. Okay, now you can also engage a student by giving a homework assignment. So this is your homework, and this is where you can engage a student. It doesn't have to be necessarily in the classroom, but the homework assignment has to be designed in a way wherein it allows the student to explore more. It should not be a question which the students can find in the textbook and answer the question. Okay, so which allows the students to explore more, right? So it could be like read an article related to a new topic to be introduced. It shouldn't be a textbook. You can read you can just read some science article which is being published in a newspaper or in a science magazine or whatever. Okay, or a small little bite, news bite, or anything. Or you can have just explore a website. What are the elements in the website? If the website is on wildlife, what are the elements of wildlife which are covered in the website? Are there any elements missing? Have they only focused on one kinds of thing versus another? What kind of information they have put? Those kind of things are good enough to engage, right? And you can even put a question like, why are acidic drinks stored in a cold place? So why are not they stored in a hot place? So this is one example. You can use more examples like this. Explore is something which looks like a lab investigation or a hands-on activity. If you are a higher grade student or a higher grade teacher, you may bring students into the laboratories, or you can design simple hands-on activities. Okay, and the teacher role here is to ask students to think around these questions. What is the problem I'm trying to solve, or what is the new thing I'm trying to explore? What do I need to find out? What do I see in the new thing? Or what do I already know? What do I already know about it? And what are those questions which I don't know about this particular problem or this particular observation which I'm doing? So those kinds of things can be done. Okay. Activity could look like, I've given one example here. So you can give them two identical soda can, a bottle opener, hot water, ice bath, and then ask them to uh, you know uh, put an activity around what will happen if you put the soda can in hot water versus a ice bath. Why are they stored in ice bath? What advantages it is giving, for the storage conditions? What kind of principles are involved in terms of heat transfer or cold or temperature or pressure effects? You can do n number of things around that. So let students engage in that. Okay. You can also ask something around which had more carbon dioxide, or list all the ways that you know. How do you come to those answers when the students are doing that? List all the ways that you know, what different ways you explored all these questions. So you can tell about that. Okay, and explain. So explain happens with teachers' guidance, but it is the students who are explaining the concepts. They explored in the previous phase. It is not the teacher. It has to be the student. Because when the student is handling something, when the student is doing all different kinds of things, when the students are learning collaboratively, they are asking questions to each other. They are saying, no, I don't think it is like that. Then somebody say, no, I think it is like that. Then how do they arrive to the consensus? How do they actually say that this is what it is? Or why they don't arrive to any kind of consensus? Few students will say, oh no, this is like this, and few will say, no, this is like this. Even within collaborative learning, what happens? And in order to support the discussion, the teacher may pose an additional question. So ask the student to explain. If I have given you two soda bottle cans, if I have given you a hot water bath or a ice bath or whatever, and what did you all do? Explain what did you all do. Don't jump into explaining yourself to the group of students. That is the biggest what to say error that the teachers do when they explain. So this is a student led instruction, and student has to be at the center of it. And then you can probably after they are done explaining, then the teacher may pose additional questions to support the discussion, or to build the explanation towards more on a convincing side, or whatever, if it is the right answer or the right scenario, whatever, that ways. Okay. So questions can make learning more meaning, interactive and participatory. So teachers should
Aditya ma'am, I'm really sorry to interrupt you.
uh,
But the screen is not moving. We are stuck on one particular slide itself.
Really?
Yes, ma'am.
Which slide is it? What do you see?
Ma'am, we have 6 questions here. Students learn through direct experiences. This is a slide that we are on.
No, what is the content on the slide?
Did your students discuss a question in small groups?
Oh, but I am moving. I don't know what happened.
No, it is still there. Like it's still stuck on that slide.
Oh, okay, hold on, huh?
Okay.
Wait, let me share again. I don't know what happened. Okay. Oh, I'm so sorry about that. So we were here?
Yes, ma'am. Now it's moving.
Oh, okay. So I'll just scroll through the slides because I've already spoken about this. Teachers are quite primed on the model. So I don't think I need to go and read through all this again. Okay, so I spoke about you can also give a homework assignment around engaging activity. The engaging activity doesn't necessarily has to be in the classroom. You can give them, this was where I gave the example of the wildlife website that you could watch and you can ask different kind of questions, what kind of information is built around that. I also gave example of this acidic drinks. Why are they stored in cold place and why not in, hot places? And this also I explained. So uh, uh, the soda can example that I gave, so perform the activity in pairs and ask the right kind of questions. Which soda, the warm or the cold one, had more dissolved carbon dioxide? All these kinds of questions you can ask. And I also touched upon who should explain in the explain phase rather than teachers. The onus lies more on the students. The activity and the instruction should be designed in a way that students are allowed to explain. Teachers job is to build in new terminologies. If students are explaining something and they are not getting the right kind of definitions, the terms, the terminology, this is where the teacher's part come into place. The teacher should not straight away start explaining using the new terminology. So if you have designed an instruction around a grade 6 activities, and in grade 6 they are going to learn new terms in science lesson, those terms the teachers can explain here whenever there is an opportunity during the student discussion, when the student is explaining and not getting the right kind of words. So this is how the explain phase should go. Okay, and these are some of the things that I explained already. Some of you said that you used only engage, explore, and explain. Elaborate and evaluate was not done. So what happens? Elaborate means students apply their knowledge to new experiences and extend their conceptual understanding as they solve a problem in a new context. So, elaborate phase may not happen in your class. Why? Because of the limits of, if it is a new experience, where do you give the new experience? The lesson is already over. Is there an opportunity that another lesson has an extension of the activity or relation to the activity that you are doing in the classroom? If yes, then you can elaborate in that lesson. You can ask students that, you have done these kind of explorations previously. Now these two concepts are related to, are you able to apply, the knowledge from your previous learning that we did in that activity, 5 activity, to this classroom? Or you can ask students to again go out in the real world scenario and bring back scenarios where they can apply the same thing. So taking the concepts of the soda bottle, which example I gave, so hot and cold temperatures, what are the other things that what are the other scenarios where temperature is a key to situations where liquids are packed under pressure, or these kind of questions you can ask, and ask them to come back in the class and discuss those scenarios. It may not happen in the same way in the same science class in the same month, but it can happen 2 weeks later or 3 weeks later. So they can be a homework assignment, they can be during classroom time, as many of you said that it depends what we are doing. And then the evaluate part. So evaluation, who does the evaluation? Again, it could be both teacher and students, but here we would say that what you are going to evaluate, The teacher will evaluate some part and the student should also evaluate, because it is the student who has constructed the knowledge. It is not the teacher who has constructed the knowledge in a 5e instruction. Okay, so students, they evaluate their learning and they demonstrate their understanding and mastery of key concepts. So they are the ones who have to evaluate. I was thinking like this, my group was thinking like this, why it was okay and why it was not okay, why this answer was not correct, it was not correct, or why my idea was not correct, because later on we found out this convincing argument around this. So then how far you have come into the activity, how well you have understood the concept, what did you do to understand the concept well, all those parts the student has to do. Now the teachers will ask, if the student is doing, what we will do. So students will do, the teacher will have to design some rubric kind of a thing for student reflection, and how well the students are using that rubric is something that can help the teacher also to evaluate. So this is one example I give. You can arrange many more ways of evaluation, but it has to be the student has to have 50%, minimum 50 to 70% participation in that. So it could, evaluation could also be a product like a presentation, poster, pamphlet, journal article, whatever you can create. It could be a video that student has made, it could be anything based on their this thing. So it could be a video in which the student is explaining, I had these four different options and or answers, and how I arrived to the right answer, how I learned new terminologies, why the other three answers were wrong. If the student is able to evaluate in this way, I think the teacher's job is mostly done. So you can give these kind of instructions to student, that that's how you have to evaluate, and then do the final assessment from your end. So the evaluation part happens by the student, the assessment of the how the class has run, how the student has performed during this, that has to be done by the teacher. Okay, so some of the tips: please start small. I'm always saying, don't try to attempt big things with big classes and with different varied levels of learning of the students you have in your classroom. Okay, so you also might design a lesson with only two components of the 5e model. You doesn't necessarily have to have all the 5e's. If your lesson already has a hands-on activity, you may want to start with engage, and you may complete in explore. Uh, you should think of more ideas how to bring elaborate into picture. So most of the teachers are doing very well with engage, explore, explain, but the evaluation, the elaborate part wherein they apply those thinking to the new scenarios, that's missing. So maybe that is an area where teachers should work more, how they can get back stuff from students. And simple activities, you can say current event story, a video advertisement, a challenge statement which is based on a common misconception can also engage students. So start with simple activities which don't take too much of time, and the entire 5e model should not fit into a single class. This is one of the myths with 5e, that everything, all engage, explore, everything I have to do in one class. It's a very big myth. Please don't try to attempt it. Okay, you can weave it around a unit. You can weave it around a lesson which is running 3 days in a week or 4 days in a week. It doesn't have to happen in one single class in those 50 minutes. Okay, so or those who are only using engage and explore, if you have two classes, you can just use one class on one part, engage and explore, or you can use vice versa, whichever way you want to do it. But don't rush through explore and explain activities in order to fit the model into a single class period. Why? Because your explore and explain activity, they are the crux of the 5e model. If a student is not given time to explore properly, he won't be able to explain properly, he won't be able to build those experiences wherein he has gone step by step into inquiring, into arguing, into putting, oh, if I'm saying this, why I'm saying this, what evidence I have generated, what I have observed. So don't do. Sometimes teachers, they put a lot of effort in engaging, because as a teacher, it's their duty to engage the student, right? So So don't take too much pressure around the engage activity. Start with simple and allow the students to lead it through. Okay, some of the other myths of the 5e model is that it is linear. It is not linear. You can use zigzag, you can do here and there. Only thing is you should do it the right way. Whichever step you are doing, do it the right way. If you are only doing engage and explain, and you are taking the explore part out, that's also okay, depending upon the activity you are doing. But if in explain only the teacher is explaining and student is not explaining, that's also not the correct way. So build the opportunities for students that they can explain, and the teacher build on that explanation the right kind of the learning that you want to see. Okay, so it is again, I would say explain phase is where students reflect on their experience, take observations. So explain phase are the teachers. I have spoken too much about it, so I will not reiterate it. Try next time you implement a 5e model, try allowing students to explain and take down the notes on that particular lesson. It will give you a lot of insight into what happens when students take the lead in explaining. So this is again uh, the recap. So engage them with a challenging situation where they can have provoking, they can ask provoking questions, allow them to, observe, create something or investigate something, allow them to explain, and then uh, put more energy into creating opportunities or giving them directions where they can apply this new knowledge that they have built and how they can come back to classroom and share it with you. And then build tools which will help students make evaluate themselves first, and then the teachers can do the assessment. I think I have one more thing which I wanted to say. I hope most of you are knowing this concept of growth and fixed mindset. It was given by a researcher called Carol Dweck, who is at the University of I think Princeton or somewhere. I don't remember the university, but she's a very well-known educationist and psychologist. So these kind of using the principles of constructivism, using the principle of 5e model, using these principles wherein you start with simple activities but focus on, you know, making students ask big questions which touch the fundamental concepts in science. I think this is very easy said than done, but this is what we should aim at. And when you try these different kinds of activities, sometimes you would see that students who are very good in standardized assessments, they are the ones who will not involve either more in the activity, or who would try to dominate the other students when they are doing collaborative learning, or sometimes these students who are the toppers of the class, who are the toppers in the standardized assessment, sometimes these students uh, they are not able to get the gist of what is happening when you challenge them with different kinds of scenarios or different kinds of activities. And I'm not talking about a homework assignment or something, but when it's happening right in the class along with different other peers, you may come across these kind of situations. So in the chat box, can any teacher say yes if she has come across or he has come across these kind of situations which I'm saying? Yeah, some of you have said yes. So why does that happen? Why does that happen? We have to understand that this happens, and this is my last slide. I'm done. I think I'm on time. Yeah. So this happens, and you all, and it's a picture I got from the internet. You can read Carol Dweck's. I am typing her name here. You can read her work, Carol Dweck. Okay. So and Carol Dweck, what have I done? Okay, never mind. So I will stop sharing because that was the last slide. I'll just speak now. So the concept here is, if you have come across these scenarios where students do very well in standardized assessment, But when you do these kind of hands-on learning or other kinds of challenging activities, they don't do fairly well, or they will come and probe you, or they will irritate you with different kinds of questions, because they are facing challenge. Why do they face challenge? Because they have mastered the art of standardized assessment very well. Now this is a new challenge, and this is where the concept of growth and the fixed mindset comes. You compare other students who are not doing very well in the standardized assessments, but when they get something new, they are the ones who lead the group. And why does that happen? Because these are the students who are not used to the rote learning kind of a concept. They are the one who are the explorers. Now for the other group, we need to explain this concept to them. The inquiry happens in the growth mindset. Okay, if you are the smartest student in the class, that doesn't mean that you are a critical thinker. So inquiry happens if you have a growth mindset. Inquiry happens when you are happy with the idea that I don't know this. Maybe the student who is coming on position 15th is knowing this or exploring this better than me. So, and this is where you have to emphasize on the concept of collaborative learning. So you build together, you learn together, and build a a kind of a learning atmosphere in those group, which is also a very very big challenge for teachers, because sometimes grouping also becomes very challenging. Array, these are the top 5 students, where do I place them? Do I place them together? Do I place them with different groups? These are the bottom 5 students, where do I place them? How should I make my groups? So these are some of the challenges which teachers face, and it is very important to bring in this concept into place, where we talk about growth versus the fixed mindset. Uh, so students should be made sensitized about what kind of mindset they are having. If they are already on the growth journey, ask them to be there, make it more. If they are on the fixed side, ask them to adopt a growth mindset, because we are not only preparing them for these lessons, we are also preparing them for life. So build these principles of constructivism, that we all learn together from each other, we all learn together from the experiences. And these class activities are special experiences which the teacher creates based on the principles of constructivism, using the 5E as an instruction, and promoting the inquiry based thinking and promoting the growth mindset across students. So I think that is where I would stop. And thank you everyone for being here. Thank you, Yogendra, for giving this opportunity.
Thank you so much, ma'am, for such an insightful and impactful session. Now, participants, if you have any queries to ask, you can put your queries in the chat box. Ma'am will be answering your queries. Any query related to the session, if you have, you can put your queries in the chat box, participants. And don't go anywhere. We are having quiz for you. Shortly, we'll be just sharing the quiz link with you in the chat box only. So I think, ma'am, no participants is having any question. We are like getting positive feedbacks for your session. Now, participants, just stay tuned with us. Thank you so much for joining us in today's second session with Dr. Adita ma'am. We hope the hands-on techniques and inquiry-driven strategies she shared have sparked fresh ideas to bring science alive in your classrooms. A heartfelt thank you to Adita ma'am for such an engaging and enriching session. Ma'am, your practical insights and creative approaches have truly empowered us to make science more interactive, meaningful, and fun for our students. And now, before we wrap up, participants, we'll be just sharing the link for the CPD quiz in the chat box, where you will have a chance to test your knowledge and win Amazon vouchers worth up to 10,000 rupees. And as always, your participation certificate will be shared via email once you complete the feedback form, which will be sent to you by Monday. Please note, participants, your participation certificate will be shared via email once you complete the feedback form, which will be sent to you by Monday. Please keep an eye on your inbox and spam folder. And now we have just shared the CPD quiz link in the chat box. Test your understanding of today's session and showcase your learning. The quiz will remain active till 11:59 p.m. tomorrow. So make sure to participate before it closes. And remember, This is just the beginning. Stay connected with us for more CPD sessions packed with new ideas and inspiring educators. Thank you once again for being part of today's learning journey.
Okay.
Agda ma'am, thank you so much. The session was really insightful and informative.
Okay. Bye bye. Thank you.
Participants, we are having the link for the CPD quiz in the chat box. You can either directly click on the link or you can copy the link and paste it in the browser to attempt the quiz. Participants, you can either copy the quiz link or you can directly click on the link to attempt the quiz. The quiz link will remain active till 11:59 tomorrow. And about the certificate, so you will receive your certificate on your registered email ID once you will be filling the feedback form. The feedback forms will be shared to you